and then you'd be done. But as I've come to learn, there are a couple more steps involved, and not all of them are necessarily obvious. So the goal at the end of this talk is hopefully you'll have a practical example that you can refer to the next time you're sailing the treacherous seas of shipping software, and hopefully this talk will keep you afloat. And that's as many puns as I have as far as for knowledgeable things. But brief introduction, my name is Sebastian. I've been writing Go professionally for about 4 years. I'm currently working as a software engineer at a company called Trustworthy, where I'm maintaining with a team and developing a project called Telegraph. So Telegraph is a man-line tool that helps you collect data, organize it, transform it, push it wherever you want. And over the past 2 years, in some way or another, I've been part of 40+ releases of this project, which is what inspired this talk, because it's a project written entirely in Go. And it's also open source, and over its lifespan, it's had about 1,000 unique contributors. So it's fairly popular, and therefore been important for us to be able to professionally and in a timely manner release it so everybody can enjoy these contributions. At the end of a release date, what we're looking for is a single binary for multiple platforms. We support 37 different architecture and platform combinations. And then we also need to update everywhere that mentions the old version number and update it with the new number. So we have an official Docker file and home charts, and some websites that need to be updated as well. But before the release date, we do a couple of things that I think helps us prepare for the release date that I wanted to cover. For example, we know when we're going to release, quite important. We have a release cycle where we have feature releases at the end of every quarter. So March, June, September, December, and then in between those months, about every 3 weeks, we try doing a maintenance release as well. Ideally, if there's no regressions, which of course never happen, or security issues. And we're actually looking into changing this release cycle to be monthly, so we have less releases, but we get feature releases out more often. But that's for next year. This is what we're using right now. And part of knowing what kind of release is going to come up is also going to determine what the next version number is. We use the popular semantic versioning, which you're most likely aware of. As in case you're familiar with the terminology, we have the maintenance releases associated with the patch. So the third number goes up, but the feature release, the second number goes up. And if a mythical major release happens, then it's a feature release with breaking changes. And being able to use semantic versioning makes automation quite easy because it's a standardized versioning convention. We use this open source package in order to parse the version in our automation tools and work with the number. In a similar vein, we've also adopted conventional commit messages in order to help with automating and making the review processes easier in the project. So if you haven't seen it before, an example on the slide where you have a required type that can be feat, fix, doc, or chore to help describe in a quick glance what the commit is, what change is happening to the code base, and then a terse but brief description or a sentence describing what the commit is as well. The Telegraph project is broken down in a lot of subdirectories where the features are known as plugins in the project, where there are a bunch of isolated bits of code. So we use this optional scope in the parentheses to describe that. And we also run a continuous integration pipeline for every single pull request, where we have all unit tests and integration tests running. And alongside that, we have all 37 different artifacts being built for every single pull request. So exactly what happens on release day is happening continuously for every single pull request. And then we've got this Telegraph Tiger bot that helps announce the fact that these artifacts are available, so they're not hidden deep into their CIR infrastructure. And this is a bot within Go that helps point this out. And it's really helped get quick feedback because before we had a lot of community members who are interested in these features and fixes, but aren't able to or have the understanding to set up the environment to package and build Telegraph themselves. So this allows us to advertise potential new changes and get quick feedback so that we can fix it appropriately. So we also like to keep things really nice and clean in the project. So we run go mod tidy, make sure all dependencies are correct, and go bump for every pull request. We've also adopted Golang CI Lint recently and gotten the project with the community's help to adhere to all of these best practices. So everything is nice and shiny, so our code base is as handsome as this gopher. We also try to make sure that we stay up to date with the latest version of Go, where we have also the Telegram tagger helping us periodically check this URL to make sure that there's a newer version of Go available so that we can adopt any new vulnerability fixes and such. So with all that kind of happening on a daily basis, kind of gives us more confidence comes release day. So when release day happens, we are all very excited and definitely not panicking. And also not to give any false impressions, I'm definitely not the only one on the team who's maintaining the releases for the project. We rotate it among all of our team members. And this kind of helps spread the knowledge and give everyone a chance to identify any quirks in our automation and help create new automation. And then we start the day by posting this in a public Slack channel so that everybody knows that we're doing the release and what step we're at. So in case anything goes wrong, you can cry for help. For the rest, I've broken down these slides into 3 different sections where what happens on the release day after we post that on Slack and we're actually doing it. So the Telegram project is hosted on GitHub, so we're using Git. So we need to prepare the branches so the code's all in the right spot. Then we build and package. So the same thing that happens for every pull request, but take a little bit of a closer look at how that happens. And then we need to announce the release, basically update all previous versions of the previous version numbers and bump it up to the new one. So for preparing the release branch, so we're on GitHub, so we're using pull requests. So every pull request is going to get squashed down and merged into a single commit that's described with a conventional commit message and then merged into master. So the master branch is then defining the latest and greatest, which is going to represent the next minor release. So on release day, we need to get the code in the right spot. Quite easy for a feature release because it's just copying a master branch into a new branch, and then because ideally we want to, the end goal is to create a tag so that we can create get the continuous integration pipeline going to create all the artifacts. And the reason we copy the master branch into a separate branch is so that on maintenance releases we can maintain that branch, because the master branch will continue moving forward. As soon as the release is done, we're going to continue merging new features into the main branch. So basically we'll have 2 branches at the end of the day, or we'll be maintaining the previous release branch. So we've captured all of that logic as code. So we've got a Go local command line tool that we run on release day to make sure that all the code's in the right spot. I've kind of broken it down in this generic run command function where we make use of the exec package that Go offers, which you can use to run external commands, because a lot of it's going to just be running git commands and calling our main file in the main target. And we just kind of wrap it around. I want to show you here, wrapping it around with a multi-writer, making use of the fact that you can output to standard out and as well as to a local buffer in case you're running a git command that needs a hash to make decisions on later. And so essentially we got this script where the backbone is this run command function. And then we've improved it ever so slightly by making use of the IO writer to the interface so that we can add some color package to help highlight what's important. And now having this run command function will allow us to make it very easy to run all the commands that we need and document it as code, but part of it also we need to capture all of the commits and have it in a parsable way so that we could generate a change log and as well as make decisions of what can go into a maintenance branch. So we need to create a slice of commits that has very broken down, that we can parse the conventional commit message and make decisions based off of it. So we use the git log command and then the pretty flag and then format it in a way that's easily parsable so that we can then capture the commits and put it in a slice. And once they're in a useful slice, we can run over it. So at this point, we're kind of manually now deciding what should go into this maintenance branch by running git cherry pick and deciding, reading the context that's given by the conventional commit message and the link to the pull request and decide if it should go to the next maintenance release. As I mentioned, the feature release is a lot simpler, where we just check it out into a new branch with the -B flag. And once all the right code is in the right place, we have to create the changelog as well. So we have this template that we can just apply that slice to, so just a Go template. And then we end up with a very generic, predictable looking changelog where we have a link to the pull request and a commit message, and all organized with, depending on the type of, the type associated. Like if it's a bug fix, it's going to be a fix. So it's a little bit more readable. So lessons learned here, I think adopting conventional commit messages has been very useful. So highly recommend that. Same thing as semantic versioning, using things that are machine readable as well as human readable allows for a lot of automation. Same thing as using Go for capturing all of this, opposed to copying and pasting it and introducing human error. We've got a script to run it. And using Go, which might come to not a surprise to the people in this room, was quite nice, because before the scripts were written in a different language that nobody knew, and the person who did know left. So, and then now it's all being written in Go, so it's a lot better. But for future improvements, so doing this manually on release day isn't the best. I would definitely recommend maybe looking into doing it continuously. I do think having some process around being able to cherry pick things on the release day and getting that process going probably an improvement, but we've got some challenges where we can't just automatically say, oh, you put the type for the conventional commit message is fixed, we go ahead and merge it. You still need to know the context of what that fix is fixing, so in case it's a feature that hasn't been released yet. So we get to the point now where we can create a tag and build and package and create our artifacts. So we use Circle CI as a platform, and it allows us to give us an overview of our workflow. I'm sure you could probably use any platform, but we have this, what I wanted to show here is we've got all of our unit tests and integration tests running on Windows, Mac, as well as Linux. And then we have all of our artifacts being packaged in separate jobs based off of architecture. So doing this has saved us like 20 minutes of build time by splitting up the jobs this way. And yeah, also the fact that we're running on Windows, Mac, and Linux, one of the highlights that the project uses a whole lot of build tags to separate a lot of functionality, where we have a lot of code specific to Windows and Linux. So it's important that you actually run your tests, and these tests have been also requiring these build tags. So it's important that you have these environments and testing on all of them, so you can capture, intentionally mistakes. And the same goes for the linting as well. That's also blocked by build tags. And the entire Circle CI pipeline is basically defined in our make file, and then those jobs are calling the make file targets. We have all of our architectures defined, just hard-coded inside of this make file, that are then split up by architecture, so that when we can run make builds, we can tell the Go tooling. So the make file really is just making use of all the Go tooling, and then just some syntax wrapped around it. For example, we need to dynamically set the version by using the linker flags, and we also embed the commit shot as well, which I thought was interesting, the fact that you can adjust these variables run during build time. And then make package after running Go build will then, depending on the platform, will use the extension that's hard-coded in the make file to package it appropriately. So we're running FBM and tar. So if you run make package locally, you'll get all 37 different artifacts, but you might most likely get a bunch of errors saying you don't have FBM installed in Ruby. But yeah, so then in the Circle CI pipeline, because we have a split up in parallel, we have these packages. This include underscore packages variable adjusted to only run the architectures that we want. I did want to point out this alternative called Mage that we don't use for Telegram, but I've used in personal projects. It's been quite nice because the makefile syntax isn't that great. It's a fancy bash, and it can be quite confusing. So using Mage allows you to use Go syntax, which is of course far superior in preaching to the choir probably, but it definitely, in my personal experience, is a good alternative. So I just kind of wanted to point that out. And part of the pipeline, we also put our official influx data stamp on everything to make sure that everyone knows it's fine and safe. But that's not very interesting. What is interesting is the way we've had to embed the icon and version into a Windows binary to get a good Windows user experience. Evidently, there are system administrators relying on the properties that you see if you right-click on a Windows binary. And there's this open source this Go version info package that's kind of solved the solution where you can add this header Go generate on your main_windows.go file, and then you can run Go generate, which is what we do in our pipeline, to embed this JSON file along with this icon. I think it translates this JSON file into some Windows garbage, but it does it magically. So we have some command line tool to basically update this JSON file dynamically, the same sense of how we update the linker flag to use the latest version. And then you end up with this pretty binary that's more familiar to Windows users. And yeah, so then they can help their automation. We also have a package repository that gets updated, but there's not much to say here. Just wanted to highlight that we do. And so everything gets uploaded to public S3 bucket as well. And this is like magic that happens through an Ansible script that nobody wants to see. And so lessons learned here, I think making those artifacts readily available has been quite nice. So feedback, we work with a lot of people in the community in different time zones, so not having to be like, hey, do you want to test this? Like, I can't build this. Oh, all right, let me build it for you. And then, a week passes by. But so this has been great. And then also it's helped us be able to replicate the release pipeline continuously. So in case there's something wrong, it comes up pretty quickly. Except for this stamping, we only do that on nightly releases, so we don't slow down the every pull request pipeline by putting our official badge on it. But we noticed that, yeah, we still would have to do it nightly because Mac has a license agreement that has to be updated randomly. So now we capture that quicker than on release day. So we got to a point where all the code is in the right place and we have all the packages. So essentially, we're in a really good spot. Now we just need to let the whole world know there is our new Go binaries to go and use. So we have a bunch of different places where the version number is mentioned, and all of them are using different file formats in order to display this version. So we have some automation written in Go to help update this as well. Of course, there's no automation here. This is a very manual process of just associating a git release with a tag, copy and pasting the changelog, and a markdown table that's linking to a bunch of artifacts with a JavaScript associated with it, even one's on the S3 bucket. And that is one place you can get the binaries, and another is this official website. The code itself is all internal, so no one cares. But what I wanted to point out is all we have to do is update a JSON file. But it's a huge JSON file that captures a whole bunch of different projects versions. So instead of having to marshal that into a large struct that we would manually have to define locally, there's a package called sjson I wanted to recommend, where you can just give a key and a version to update your specific package. And that makes it a whole lot easier. We also then support an official Docker file. So if you haven't had to do that before, we have two repositories. One repository that contains our Docker files with 3 supported versions and a manifest.json file. And that then gets updated using that semantic version package again and taking out the oldest version and putting in the newest. And then that magically gets transformed into whatever format official Docker uses. I have no idea what they were thinking about not using something easy, but essentially it's a second repository that has just a SHA pointing to the Docker files being used. And yeah, so there's some magic code transforming this manifest.json into this format, but it's not pretty. But what is pretty is this test containers package that we use to test. So we have this Docker file, the version gets bumped up, to do a sanity check. We then execute it and get the version. Using this test containers package has helped us be able to do it all within the same automation script. So while we're running through it, it will run and tell you that everything is correct. We also use this for our local integration tests that have, this test containers package has made that so much simpler. We also have Helm charts that needs to be updated. So evidently they use a YAML for their preferred file format. And unfortunately, I couldn't find anything as nice as the SJSON package, but you'd have to manually walk through the contents of the nodes in order to update it. And then you end up with this. So I thought just kind of funny, we have all these scripts to update just like one number in a bunch of different files, but it does help with reducing human error in case, because it definitely would never happen with somebody typing the wrong version number. Unheard of. So yeah, lessons learned here is once you get to this point of the release, there is no turning back. You have made the release. The moment you hit that publish the GitHub, the release, it could trigger other people's automation. And for our case, we have third-party maintainers of repositories like for Brew. And basically, if you go in and change the binaries at this point, like, oh, we forgot this commit or something, the hash will change, which would then, of course, cause concern because it could look like a security vulnerability. So at this point, you want to go back in time and start from the beginning again, and do the fun all over, and just increment the patch number, and just be public about why you're doing this change. I wanted to end with mentioning a major release. So we, on the Telegraph project, it's been a while since we've done a major release. We kind of also want to keep the releases boring. We want to make sure that people's configurations don't break. So yeah, package compatibility is quite important. So this is it's going to be a challenge in order to get to the next version, but hopefully we're going to do it in the next year. There are a couple of more processes of how we want to get all of our branches in the right spot and get all the breaking changes in the right spot. But I think it's important that we get into the habit of doing breaking changes in a non-breaking way, where we still have backwards compatibility, kind of releasing the 2.0 without making it a big deal. But yeah, so that was it. That was my last slide. So I appreciate everyone for listening to me. If you have any questions, I guess feel free to stop me somewhere and I'll give you a 3D printed gopher for your time. But that's it. Thank you very much.